Welcome back to the hyperbolic coding chamber. It is day 164. So we are back once again post a nice and thankful turkey day. So hopefully that was well. But you know what's even better? The comments. So we have a comment from ADC, happy Leetsgiving. I'm leetful for the hyperbolic coding chamber. I mean, need we say more? Need we say more? So the hyperbolic coding chamber, I'm grateful for the hyperbolic coding chamber Discord. So we have a legendary algorist, the Control C Ninja himself. Feels strong, man. Feels strong, man. Happy Leetsgiving. So hopefully it'll be interesting to think about how far we'll be at the next Leetsgiving. So that could be pretty cool. Then we have a comment from Jishnu Dasarkar. Love this channel. You motivate me so much. Appreciate that. I'm just trying to get like you, brother. Hey, feels strong, man. Feels strong. Oh, wait, I didn't even, yeah. So, by Jishnu Dasarkar, feels strong, man. Just trying to get like you, brother. So, hopefully, going forward, we can have more motivational Discord talks about Leetsgiving. So, we have to organize something for next Leetsgiving. So, make sure to mark that on the calendars. And, yeah, it could be pretty dope. So, I'm going to be jumping straight into LeetCode today. Going to be a little bit shorter just because it is indeed Leetsgiving, the day after Leetsgiving. So it is what it is. But I think tomorrow we'll be back to regular hour each. And these are just, I guess these are sort of like off days where we still do work, but not too much. So hopefully we can still fry quite a few problems and see where we are. So I'm going to jump into it. We're going to continue with rotate string. So here we have rotate string. So given two strings S and go, return true if and only if S can become go after some number of shifts on S. After some number of shifts on S. A shift on S consists of moving the leftmost character of S to the rightmost position. So it looks like popping it from the front and moving it to the end. So for example, if S equals A, B, C, D, E, then it will be B, C, D, E, A after one shift. And so we want to know if S can become go after some number of shifts. So if we have A, B, C, D, E, A, right? If you do 7 shifts, then it should be able to become A, B, C, D, E. We do 5 shifts, A goes to E, B. Oh, we have a goal. Right, I see what they're saying. Interesting. So if we have C, D, E, right, and we end here, we have to go back around to A, B, and they would indeed match. We have A, B, C, D, E, and the goal is can we make A, B, C, E, D? Doesn't seem too bad. Doesn't go. I think you could just remove characters from the front of A and move them to the end of E. And once we've done 5 shifts, if we've never equaled the goal, then you can't become goal. So you have A, B, C, D, E. A will move to the end of E. B will move to the end of that. Right, we keep going until C would be first, and then eventually, if we check if they're the same, they would be. So I think that could work. The issue is popping from the front of a regular array would be, or moving from the front would be linear time. And we're going to do that at at most n times. So this could be n cubed, I think, since the comparison of A, B, C, D, E equals another string is going to be linear. So I think we could do that. So we could just rotate the string, and they say a rotation is moving the leftmost character to the rightmost position. So move from the front, add to end, and check if it equals that. And I think that would be, actually, if we do that at max 7 times, we should get, we have the loop for let I equals 0 I is less than s dot length, I plus plus, and if we make it down here, return false. And we have s, we move it from the back, add to the front. I think one thing we have to check is if s equals goal, could return true. And I guess, yeah, we could have the string, but we're just going to spread it into an array. And we'll just say front equals r dot shift. And we'll do r dot push front, and we'll say, okay, does r dot join, which is kind of bad. Okay, let's not turn it into an array, and let's just remove the first character. So we'll just do dot substring, and we'll start at 1, so 1 index forward, and we're going to go to the end. We're just going to be s dot length. And we can just do some string interpolation to get this. And then we'll do s sub 0 like so. We'll say if stir equals goal, return true. Okay, well, we'll take it. It's not the fast, I think, yeah, it shouldn't be too bad. I think linear iteration over the string. String interpolation saves us from doing a join. And then we do a linear check of the characters. It should be n squared in the worst case time complexity. With linear space, but and again, you could just reuse s. So we'll say constant space if you remove string and just make everything that says string say s. So it looks like it's faster, but for no reason, so. Wait. All rotations of A are contained in A plus A. Thus you can simply check, oh, that's true. If you have A, B, C, D, E, A, B, C, D, E. You can just check if it's a substring. That's still n squared though. The KMP algorithm is a textbook algorithm that does string matching in linear time, which is faster than brute force. We could also do linear time by implementing stir on an implicit A plus A without actually constructing A plus A. That's actually really clever. So you could get linear time. Interesting. Oh yeah, we were working on number complement. Did we solve this? Okay, we did solve this, so we can remove this one too. You're given a license key represented as a string of You're given a license key represented as a string of S that consists of only alphanumeric characters and dashes. The string is separated into n plus 1 groups by n dashes. So if you have 3 dashes, we have 4 groups. You're also given an integer k. We want to reformat the string S such that each group contains exactly k characters, except for the first group, which could be shorter than k, but still must contain at least 1 character. Furthermore, there must be a dash inserted between groups. You should convert all lowercase letters to uppercase. Return the reformatted license key. So we have S, we have 4 groups here. And they want us to reformat so that each group contains k characters, except for the first group, which could be shorter than k, but still must contain at least 1 character. We want to reformat the string such that each group contains exactly k characters, except for the first group. We want to reformat the string S such that each group contains only k characters, except for the first group, which should be shorter than k. So can there be any order? Are they retaining the order? They're still retaining the order. Interesting. You are given a license C represented as a string S that consists of only alphanumeric characters and dashes. The string is separated into n plus 1 groups by n. So we have to count the number of dashes to know the groups. So this is given an integer k. We want to reformat the string S such that each group contains exactly k characters. I want to reformat the string S such that each group contains exactly k characters. I want to reformat the string S such that each group contains exactly k characters. Except for the first group, which could be shorter than k. It still must contain at least one character. Furthermore, there must be a dash inserted between two groups, and you should remember that all lowercase letters to uppercase. Interesting. I think we could figure this out. So if we had a groups array, this would basically be an array, an array of strings, basically. And the first array would get the value of at least one character, because it must have at least one character. And then I think what we could do is we could say while s.length does not equal 0. Then I think we could just return groups joined by a dash. And the goal here would just be to check how many characters are left. So we would have to say that s is equal to s.substring 1 to s.length. Then we'd say if s.length is greater than or equal to k, so we can now chunk a group of k characters, right? Then we'll just say that groups.push s.substring go from 0 to index. Actually, now I'm thinking it's just an array of strings. Yeah, something's awkward about this because it's just telling me exactly what to do. Then we'll push the substring onto group. And then we'll do s is equal. So we can actually have like let sub equal s. I'll say s dot string. I will say go from index 4 inclusive to s dot length. And then else, we'll say s, we'll say groups sub 0 is equal to group sub 0, right? And we'll just string interpolate whatever is there, right, with the rest of s. Oh, and oh, we probably have to remove the dashes first. Oh, and then we'll turn it back to a string. Not equal dash to string. Maybe we should just do join. For all lowercase letters into uppercase. Oh, they do want it in a specific order. So it seems like we want to put the first K characters on hold. We want a very specific order. I guess I'm thinking you have to hold the bucket. So you could say 5E9W. We hold the first 4K, the first K elements, or the first K numbers, the first K symbols. Let me see the second test case. If I change this to, if I add one more character, turns the total length to 4, turns to 6. So what if I change this, add one more character, and I change k to 3? Oh, I said 4 here. We want this to be k. So with 7 characters, it did 7 mod 3, we'd have 1 character remaining. And that's how many characters we should have for the first group. So we could remove this. Then instead of doing s sub 0, we can just do s dot substring, start at 0, and we'll do k, or do s dot length mod k, and that's how many characters we should get. In fact, it should probably be after we filter out the dashes. Actually, it's not that simple. We have to like this. Say if s dot length mod k equals 0, then we'll just work as usual. Greater than or equal to k, then we'll slot it into the bucket. In fact, we could probably remove this. Otherwise, we'd say s is equal to s dot substring, starting at 0, going to s dot length mod k is what we would start with. But before we do that, we'd say groups dot push s dot substring 0 mod k. So k is 3 here, output is 2, which makes no sense. So here we have 1, 2, 3, 4, 5, 6, 7. 7 mod k, which is 3, gives you a remainder 1. I'm going to say s dot substring went from 0 to plus 1. Actually, no. That's how many characters you should include. So we have 2 as a group, and then we have S. Oh, this is supposed to say S dot length going. Okay. Okay, that was sort of a mess, but we'll stop there for today since we solved it.